Alright, we're back again at it again with more integration by parts. The best, worst, I don't know why, but it's surprisingly fun to do. X squared times e to the x. You can't do this through normal u du, you can't pay your dues, so we're gonna have v visit his friends here. So the integral of u dv equals u times v minus the integral of I'm always the way I like it. I like e to the x up front, but I haven't decided what my u and v are. Well, I have decided really, but minus the integral of du and v. V visits his friends. So we want du to be something. What could we do here? Let's do Lipit. Lipit's not a camera. Lipit. So u v are u. Do I want you to be the u? I don't think I want you to be u, actually. I want you to be dv. And u will be the u. So u times v, that'll just be, well, let's write our stuff down. U equals x squared. Du equals 2x. dv equals e to the x. The integral of e to the x is just, guess what? E to the x. So let's plug into our formula. Oh yeah, as always, I. This is included in our I, meaning integrand. So that way if we ever make it cyclic, focus, yes. So if we ever make it cyclic, then we just label it as I to make our life so much easier. So x squared times e to the x minus the integral of du dv, or duv, which is 2x e to the x. We do not like constants here. I'm going to work back here. Nobody likes constants. So minus 2 to the integral of x e to the x. So immediately, oh, can we? No, we can't make it cyclic. It'll never be cyclic in this state. But we can definitely get it down to where we can uv it again, to where x just becomes 1. So it'll just be the integral of e to the x, which we know is just e to the x. So equals x squared times e to the x minus 2 brackets u equals x, du equals 1, let's do dv on the bottom, keep it even, dv equals e to the x. What's the integral of e to the x? E to the x. So u times v, e to the x, minus the integral of 1 times e to the x, which is just e to the x. So we could, technically this is our answer. Because let's e to the x minus e to the x negative 2. I would say this is our answer because we could distribute it out and then factor out the e to the x. Which, do you really want to? This is AP Calculus, not AP Algebra 2. But, I mean, I don't like factoring, and I don't like my Algebra 2 skills, but might as well try it. No, u equals e to the x minus plus 2 e to the x squared times e to the x. We can factor out an e to the x here. You know, e to the x squared minus 2x plus 2 equals, we were not done. We were never done, actually. Is that plus c necessary? Yeah, no, that's the plus c is necessary. I skimmed over a lot of the work here, but more or less, it doesn't become cyclic. Cyclic. The I is not necessary. We follow the integration by parts formula. U equals x squared, du equals dv equals e to the x. We do our old magic. It never becomes... That's a bad integral. It does not become cyclic. We can't make it become cyclic. But at the same time, this x can just become a 1. So that means we did choose the right u. Because if u can reduce itself to 0, that's why we always do... u is a polynomial in this case. Yep. Oh yeah, limit never always... It doesn't always work. It's good to just write this down so that way you know. Why did I put a 0 there? Oh, because the polynomial can reduce down to 0. And that's a good way. If it can reduce down to 0, it's your u. Which in this case, we can reduce it down to 1, meaning we don't need to integration by parts anymore. So, 1 times e to the x, e to the x. Integral of e to the x, e to the x. Technically, you could just end it here, just add an x squared times e to the x plus c. That's very bad handwriting. But you could just end it like right here, like all of this gone. This could be your final answer. But yeah, fun integral. It's like 2 a.m. The storm still hasn't hit, and I'm still doing integration by parts for fun. Hopefully the next video will be chemistry if I end up doing my chemistry homework, but I don't like chemistry. We'll see. We'll see, though.